All right, we're going to talk about 6.3. You need your notes for 6.3. We're going to talk about square root functions. Square root functions. So we are at 6.3. When you graph a square root, if you think about what it would look like in an XY chart, this is the parent function, the square root of x. Y equals the square root of x. This is what the graph would be. 0, the square root of 0 is 0. Notice the domain. Domain would be 0 included to infinity. You cannot take the square root of a negative, so x cannot be a negative. 1, square root of 1 is 1. And then you could do the square root of 2 is like 1.4. Obviously, you wouldn't really do that. Square root of 3 is like 1.7, and then we should know the square root of 4 is 2, and then the square root of 9 is 3. So that's why you get this. Now it does not. It will continue to go up. Square roots of really big numbers are still really big numbers, but this is the general graph. So if you find 1, 1, and then you find 2, 3, 4, 2, and then if you think about how this shape will go, it will continue to go up. It'll just go up at a slower rate. The square root of 100 is 10. Think about where 110 would be. So you look at the important things. Remember, end behavior, we would write the limit as x approaches infinity. The function approaches or is equal to infinity. Okay, and then we don't have end behavior on the left. It does not go to negative infinity, so that's the end behavior. So the range is the same as the domain here. It's 0 to infinity, and our main focus for this section is going to be, can we sketch graphs when we move them, and can we sketch can we find the domain and the range? Now, we've seen this before. Transformations, H and K. H is going to be the horizontal translation. K is going to be the vertical translation. If you remember back to all of the different translations we've done to this point, you have things like y equals a times x minus h squared plus k. That was a thing that we did. We move h units left, right, k units up. Now it's the same idea. H is the horizontal translation. Please note that the minus is in there, so you want to be careful for the minus being in there. You have to deal with that. And the k is the vertical, so it's up and down k units. A, if a is negative, look down here. A is negative. The graph is reflected across the x-axis. So if I had y equals negative square root x, we would go in this direction, right? We would go down in this way, because all of my y values, I take the square root of 1 and I'd make it negative. So it would be 1, negative 1. It would be x is 4, negative 2. If a is greater than 1, we're going to have a vertical stretch. It's going to go up faster. Think about taking the square root of something and then multiplying it by a number bigger than 1. You're going to, like 4, you're going to go up quicker. It would just be steeper. If you have a fraction between 0 and 1, then you're going to go up slower. It's compressed vertically. Identify the domain and the range of each. The first thing I like to do, let's call this one maybe number 1. We'll do that down here, number 1. We're going to go, this is going to be y equals a times the square root of x minus h plus k. We're not going up or down. We're going 2 to the right. We're going to go 2 right because the value of h is positive 2. So my domain will be from 2 to infinity, right? Correct? This is going to be vertically stretched, so let's call this one number 2. Let's do this right over here. This is going to go 4 to the, watch out for that plus. This is like x minus negative 4. And if you're subtracting a negative, you're actually adding. So the value of h is negative 4. This will go 4 to the left. And we will end up with negative 4 to infinity. So really my domain is going to have a lot to do with am I moving to the left or am I moving to the right? One thing that we don't make note of on this previous page is what happens when we change the value of x to a negative. So that is one thing we do need to make note of. When we go, let me just, if this is y equals the absolute value of x, and this is y equals negative absolute, or excuse, not absolute value, square root, and it goes like this. What does it look like when we do this? So this is a reflection when we negate the entire function, we reflect down. This is going to be a reflection to the left because now I'm going to only be able to put negatives in here. So I'll go 0, 0. But I'll put a negative 1 in there. Negative, negative 1 is 1. So I'll actually go over here. So it'll be here, here. Think about putting negative 4 in there. Negative, negative 4. And we'll end up going like that. So when we negate the entire function, we reflect over the x-axis. It goes down. When we negate just the x value, it reflects to the left. So you just want to kind of make note of that. Most of ours are going to be just like the ones that you see here in front of you. Graph the function, state the domain and the range, and note the end behavior. So I see a value of a. If you compare this to y equals a times the square root of x minus h plus k, I see a vertical stretch, means it's going to go up faster. And I see, by a factor of 3, I see right 4, and I see up 2. So I'm going to go 4 to the right and 2 up. That's going to be my starting point, and I'm going to go up this direction. Okay. Now, instead of being the 1, 1 idea, this will actually be like a 3, 1 idea. So I do know that I'm going to end up like this, but how can I get values that I know are going to work for that? I could plug in an XY chart, or I could put it into my calculator. Please make sure that you get that into parentheses. And we could get another point or two. So for example, if I put 5 in here, if I put an XY, so I know I'm going to be at 4, 2. I know 4, 2 works because that's what the H and K does. But if I put a 5 in there, that's 5 minus 4 is 1. Square root of 1 is 1. 3 plus 2, I get 5, 5. And that's where I knew to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And then I could put a 6 in there, but it's going to get a little bit ugly. So the next number that you can put in there that can have a nice square root would be 8. Why do I know it's going to be 8? Because 8 minus 4 is 4. Square root of 4 is 2. 3 times 2 is 6 plus 2 is 8. So I get 8, 8. So I get 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I hit it pretty good. And that would be enough to sketch the graph. We just want a general shape. Get a couple of points. We know we have a vertical stretch. We know we're 4 right. We know we're 2 up. Domain is going to have to do with the x's. That's going to have to do with the h. I'm going to go from 4 to infinity. My range is going to go from 2, that should be a 2 to infinity. End behavior, the limit as x approaches infinity, the function goes to infinity. We do not have end behavior the other direction. Please watch out the negative. So I know I'm going to reflect down. I'll be going down. And I know that this is going to make me go, so I'm going to flip over the x-axis. I'm going to go left 5. Watch out for that positive 5 underneath there. X minus h. And I'm going to go down 6. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And now, normally I would just be going up like this. Instead, I'm going to go down this direction. Down this direction. Okay, so if I put a -4 in here, -4 plus 5 is 1. The square root of 1 is 1. I get -1. -1 minus 6 is -7. So I get -4, -7. I'll be there. And then if I put -1 in there, again, you could get these off of your, you want to think about making this into the square root of 4. -1 plus 5 is 4. Square root of 4 is 2. -2 minus 6 is -8. So I get -1, -8. And you can see that shape. You can see it coming into shape here, where we're going to end up going like that. And I got a domain. Again, it has to do with the x's, and I'm going to be from -5 to infinity, and I'm going to have a range. I'm going to be from, ooh, you got to watch out here. I'm going to go from, whoa, I got to redo this. I'm going to go from down all the way up to the -6, because this is going to continue down. Remember, it'll keep going down, even though it doesn't seem like it. It will keep going down. Match the graph. I would start with the fact that this is +3. So in this one looks like a negative. And I would go right 2 and down 3. Which one's going right 2? And this guy right here. Right 2, down 3, opening up. The 3 makes it go steeper. Got it. Okay, I think that's good for 6.3. It was fun.